Section 1.2, Example 4. The quantity demanded X of a particular calculator is 2,000 when the unit price P is $85. For each decrease in unit price of $30 below $85, the quantity demanded increases by 300 units. The suppliers will not market any calculators if the unit price is $55 or lower, but at a unit price of $118, they are willing to make 3,510 units to make available 3,510 units in the market. If the demand and supply equations are linear, what is the equilibrium price for this particular calculator? Okay, so we see that word equilibrium. So we know that we're being asked to find the point of intersection of the supply and the demand curve. All right, so it appears that we have a lot of information in here, but if you look at it, we see that this first sentence and that second sentence are talking about demand. And then after that, the next sentence is talking, the next two sentences are talking about supply. Okay, so we basically need to repeat our process twice. So first we need to find the points that are on the demand curve, find the equation of the demand curve, and then do the same thing for the supply curve. Find the 2 points that are on the supply curve, and then find the equation of the supply curve, and then we can find the point of intersection of those two lines. Okay, so we start out with the demand curve. So we keep in mind that for both supply and demand, our points have the form x comma p, where x is the quantity and P is the unit price. So if we're looking at that first sentence, the quantity demanded X of a particular calculator is 2,000. So X is 2,000 when the unit price P is 85. So we have that point 2,000 comma 85. But then we're told that for each decrease in unit price of $30 below $85, so if we subtract 30 from 85, that gives us a price of 55, the quantity demanded increases by 300 units. So instead of 2,000 units, it will now be 2,300. Okay, so that second sentence there we can use to interpret a second point, or we could just use that second sentence to interpret as the slope. I've just found that it tends to be easier just to use that to get a second point. Okay, and then over here for the supply curve, we're told that the suppliers will not market any calculators if the unit price is $55 or lower. So will not market any calculators. So that means the quantity is 0 when the price is 55. But at a unit price of $118, so P is 118, they will make 3,510 units available. Okay, so for both of them we have our 2 points. So now we know 2 points uniquely determines a line, so we can find the equation passing through those 2 points. Okay, so our slope is the change in P over the change in X, because we're dealing with P instead of Y. And so that would just be 55 minus 85 over 2,300 minus 2,000. So 55 minus 85 gives us negative 30. 2,300 minus 2,000 gives us 300. So that reduces down to negative 1/10. Okay, so keep in mind that if we're looking at this slope right here, negative 30 over 300, that is exactly what that second sentence says. For each decrease in unit price of $30, so if the change in price is a negative 30, the quantity demanded, the change in X, is a positive 300. So we could have gone straight to that statement right there, given that sentence. Okay, so then we need to find the equation. So remember, we have multiple ways of doing this, but I'm going to use the slope-intercept form. So P equals mx plus b. So it's just P instead of y. and then I need to plug in one of my points and my slope. So I'm going to use my first point, and I'm going to use my slope. Plugging in, I get 85 is equal to negative 1/10 times 2,000 plus b. So we have negative 1/10 times 2,000 gives us negative 200. So we have 85 is equal to negative 200 plus b. If we add 200 to both sides, we get 285 is equal to b. So we know that our slope m is negative 1 over 10, and our y-intercept b is 285. So therefore p is equal to negative 1/10 x plus 285. So that there is our demand curve. If we come over here to the supply, we already found our 2 points on our supply curve, so we do the same thing. Our slope is the change in p over the change in x. So 118 minus 55 over 3510 minus 0. 118 minus 55 equals 63. So 63 over 3,510 reduces down to 7 over 390. Okay, so this is our slope m. We also notice that we are given the y-intercept, so we could go through and solve for the y-intercept like we did over here on the left-hand side, but here we're given the y-coordinate when x is 0. So the y-intercept b is 55. So therefore our supply curve is p equals 7 over 390x plus 55. Okay, so we have our demand curve, we have our supply curve. Now we need to find the point of intersection of these two lines. We can find the point of intersection either algebraically or by using the calculator. I'm going to go ahead and just let the calculator do the work for us. So I'm going to put the demand curve into y1. I'm going to put the supply curve into y2. Let's go ahead and pull up our calculator here. So y1, we have negative 1 over 10x plus 285. Into y2, we have 7 over 390x plus 55. Okay, so again, you can start out, do a standard zoom, so zoom 6. But again, here we see that we don't see anything on our calculator. So then we keep in mind that we're talking about supply and demand curves, so it doesn't make sense to have a negative quantity or a negative price. So we know we're going to be limited just to the first quadrant, so therefore we know that our x-men and our y-men must both be 0, so that we're limited to that first quadrant. And then to find our appropriate viewing window, I tend to always look at the y-intercepts. So here our y-intercepts are 55 and 285. So I need to choose our y-intercepts to be large enough to see both of those. So I'm going to, or our y-max to be large enough to see both of those. So I'm going to choose my y-max to be 300. And as a starting point, I'm going to choose my x-max to be the same. And it's just a trial and error process that we go through to get the appropriate window. Now we can actually see two lines, but we see that they are not intersecting anywhere on this screen. We know they're going to intersect somewhere way out here because we see they're nowhere near one another. So what I need to do is increase the x max so that I can see where they intersect. So if I go to my window, I need to increase my x max, let's say maybe 2000. So it looks like that might have been good enough, but so I can get a little bit better window, I'm going to make my x max 3000. And again, it's just a trial and error process. And so now we can actually see the point of intersection. So on that previous window, it probably was good enough to be able to find that point of intersection, but I just adjusted it to get a little bit better viewing window. But now, since we can see the point of intersection on our window, we can ask the calculator to find it. So we go hit second trace to go to that calc menu, and then we select option 5, intersect. Again, if I have just 2 straight lines in my calculator, I can just enter through all the options. If not, I can use the up and down arrows to switch between the curves. But it says first curve y1, I hit enter. Second curve y2, I hit enter. Again, since I'm dealing with straight lines, they're only going to intersect at most one point. So I can go ahead and hit enter for my guess, and I get the point 1950, 90. And again, the way I show my work here is I tell the reader what I entered into the calculator and where. That's what I did here. The function used on the calculator, which was option 5, intersect. And then what the calculator returned to me, which was the point 1950, 90. Okay, so this x coordinate is the x was representing quantity, so this is the equilibrium quantity. And then the y coordinate is actually the p coordinate representing price. So this is the equilibrium price. Okay, so since p was representing the price in dollars, we would say that the equilibrium price, because that's what we were being asked to find, is $90.